Okay, it's been a long time, but I finally filmed another video. It's not because I haven't been in the shop or haven't been milling or working in blacksmithing. It's just I haven't been filming it. I've been having too much fun doing it. But I'm finally getting this Syil X7 dialed in, figuring out the feeds and speeds. The biggest hurdle, I think, was to really get some good high quality probing. The tool setter was easy. The probe, though, the Pioneer probe, it took a little while for me to wrap my head around to understand the macros and the programming. To get it concentric, I had to adjust it. When I put it on in the spindle, it was about, I think, 30 thousandths of an inch, and I have it now within about, well, it's inside of 1 thou, 0.001 inch, or about, I think it's about 25 microns, right? But the project I'm going to show you it's a flip part, but it's a very simple part. It's a soft jaw made out of low carbon mild steel, but it's going to really test the quality of my probing, because when I flip it, take the hat off, and then get a new work coordinate system center top, when I put in this chamfer, I'll know at that point, well, I already did it, that I'm cooking with gas, which I am. So I'm going to pull you in closer and I'll show you exactly what we're going to do in the video. This is a very primitive Flintstones screen record. You're actually looking at my laptop. So I've got, this is the soft jaw. This is showing my first op. Let me just go through the ops, and then we can do a simulation. So the first op is the inside face. I'm going to face it with a 50 mil or 2-inch cutter, face mill. Then I'm going to do a little contour with a 12.7 or 1/2 inch end mill around the sides. This is actually where I need to figure out how to tweak, how to use Fusion 360. For the last 2 months, I've only been milling with Mastercam on Haas mills, and I'm getting snipe in these corners here. In fact, I don't know if you can see that, but I'm getting little snipe marks on the corner. So something I'm going to be figuring out. Then I'm going to use a center drill to start these, to locate these holes, and I'm going to drill them out. My screws are 8 mil, so this is clearance for 8 mil, so it's about 9 mil. And then I'm going to come in here with a helical bore, 3/8 end mil, or quarter in this case. And I'm going to bore these down about 12 millimeters, just enough clearance for the socket cap bolt to go in there. And then chamfer. Then on the back side, op 2, the first thing I'm going to do is I'm going to take off the hat so I can have a machine surface where I can get a new origin. And that's op 3, is the back. After I've got a new WCS, I'm going to come in here and contour it. So the whole thing, if you care, that's the other CNC going. Thanks, Lori. Okay, so let's see here. Hard to drive with the camera in the way. So face, contour, spot, drill, helical bore, chamfer, and then again we'll flip it, take off the hat, probably the longest part of this op, and chamfer. So there you go. As far as feeds and speeds, boy, I am running this mill in millimeters, because millimeters, right? It's only right. All the speeds and feeds are what the manufacturer recommended, just your stock feeds and speeds, nothing fancy. I mean, I think on the end mill, this isn't going to make much sense to the Americans out here. So here's your typical speeds, 152 meters per minute, which is, I think, for this right around, I don't know, what is that, 450 feet per minute. And then a chip load, where's the chip load? Feet per tooth, that's 0.0762 millimeters, and that probably equates to about 3 or 4 thou, if I remember correctly. And everything is pretty much the same as that. So there you go. Enjoy the quick video. If you have any feedback, any questions about what I'm doing here, leave them in the comments below and I'll answer them. Ciao.